And we will get started. All right. A square and a triangle have the same area. So this actually is like those geometry problems we were doing over the summer. They actually had a number of these where they said like the cylinder and the, I don't know, the cube or something had the same area. But we should draw a picture. There's a square. Uh, so the triangle, you got to be careful of like the most basic one you could probably draw is a nice right triangle with a base and a height. Okay. And then we'll probably redraw these with like the more formal letters. Don't do that. Okay. Not you. All right. So the base of the triangle is 3 centimeters less than twice the side length of the square. So let's call the square x, x and x. The base of the triangle is 3 centimeters less than twice the side length. So 2x minus 3. The height of the triangle is 2 centimeters more than the length of the square. So the height is x plus 2. Is that okay? Is that clear?
Yeah.
Okay, so the area of a square is x times x, or x squared. The area of a triangle is 1/2 base times height, but we know the base. The base is 2x minus 3, and the height is x plus 2. And what do we know about the areas? They are
The
up here
same.
in the top. They're the same. Yeah, really important there. You've seen me circle keywords for months now. You want to get in the habit of doing that. I never did that as a student, and I should have. Would have helped, truthfully. So we're setting the two equations equal to each other. X squared equals 1/2 2x minus 3 times x plus 2, because they're equal.
All right.
All right. So now, how are you going to solve this? Well, you're going to FOIL this, then we'll deal with the x squared. All right, so let's FOIL it. We got 2x squared plus 4x minus 3x minus 6. But you have this 1/2 here. Now, typically as a student, what you'll do is you'll multiply that in. I would actually multiply both sides by 2 to clear it, because I'm kind of looking ahead to see like, oh, it's going to cancel with the x squared. That's what I would do. Now, if you really want to, we can multiply it in. What would you like to do here?
We can just multiply it by 2 on both sides.
Good choice, really good choice. All right. So you multiply by 2, you end up getting 2x squared equals 2x squared plus x minus 6. And the nice thing is those go away. If you multiply in by 1/2, it still would go away, but just a thought there. 0 equals x minus 6, x equals 6. All right, so that is not the answer, though. That is the value of x. We have to be really careful here in these problems. Once you get that, you have to go back, like, what is it even asking for? It is asking for the lengths of the square. The length of the square is 6 and 6. But it might also ask in another problem, it might ask for the length of the, or base and the height of the triangle. And you would have to, find those values. This is 9 and this is 8.
Got it. So then that would make the side length of the square 6. Or it'd be the other side lane, so actually fix for this side.
Any follow-up to this or thoughts?
Uh, yeah, I think I got that question now.
Okay.
Um,
We're not filling out the variables, the numerical answers. I mean, hopefully those are okay. You can see I tend to work in this direction, this kind of this L shape, but um, you know, don't forget to do the other ones. Those would be important to have.
all right. I put the next one in the chat. This is the next one.
It is. Triangle is an area of 1 square inch. Okay, let me make it a little smaller. A triangle is an area of 1 square inch. So we might make, make a note of that, that has an area equal to 1. The height is 1/6 an inch longer than the base. So here's the base X. The height is 1/6 longer. So the picture is important. I thought we were maybe drawing two. I should make this a little bit larger. Let me see if I can just increase the size here. Yeah, look at that. Okay. That's good. So we got the base, we got the height. We know that the area of a triangle is 1/2 times height. Again, notice I'm drawing a right triangle. I'm not drawing like a equilateral triangle. Those aren't useful in this course. They've got to be something with a, base like that.
Got it.
Now, um, we know the area is
Um,
1.
yeah,
Go ahead.
so I wanted to ask something. Would you, in this case, would you just plug in? Yeah, I was gonna ask if you just plug in x and x plus 1/6 for base and height, since those are the values.
Yes. I would also do a few more things, which may not be standard. I would first clear the fraction. Really, I'm anti-fraction. But I mean, you can deal with it, but it's just, it can cause problems. So again, I'd multiply everything by 2. Actually, let me do that down here. So 2 times 1 times 2. 2 equals x, x plus 1/6. And then I might multiply by 6 to get rid of this fraction here. Not mandatory, kind of your call on that, but I would consider doing that. That's not standard. Most people would probably just distribute in and then move the 2 over. So let's do it the standard way. So this is x squared plus 1/6 x, and then you would subtract 2 from both sides. And this is where you have not that many options. You cannot factor. Factoring can be very difficult. I mean, you can, it'd just be really hard. Completing the square would actually be probably the best choice, although not most students not preferred choice. Quadratic formula, graphing. What do you think you guys would do here? And that was the other reason of multiplying by
Um,
6. You would get rid of the
the
fraction and maybe be able
past
to
ones
get.
I've just done quadratic formula. On one of them, though, I did do complete the square, but for the most part, quadratic formula. But for this one would be easier to do complete the square. So it's
So yeah,
probably
so let me just propose. Well, it's up to you. Do you want to complete the square on this, or use quadratic formula, or
yeah, we
other?
can go ahead and do complete the square.
Okay, it's not as bad as you think, because the the 1/6, half of 1/6 is 1/12, and when you square it, it's 1 over 144. That's what you add to both sides. So this becomes 288 over 144 plus 1 over 144. And wouldn't you know it, it becomes two numbers that have a perfect square of each. It's kind of neat. So when you complete the square like this and you're solving, you don't move the number over. You square root both sides in this step. Are you caught up here?
Yeah.
All right. All right, so square root of both sides. Square root of both sides is plus or minus. So it's x plus 1/12 equals plus or minus 17 over 12. These are carefully chosen to work out, so don't be surprised that they do. And then you subtract 1/12 from both sides. I always prefer to put that in front. That way it's easier to do the calculation. You don't miss the sign. So it's negative 1/12 plus 17 over 12, negative 1/12 minus 17 over 12. Because we're dealing with a physical problem, negatives don't make sense. So this is the only possibility, which is 16 over 12, which is 4/3.
Uh,
But that is not the answer. Even though we've done all this work, it's like, oh my gosh, what do you mean it's not
you
the
have
answer?
to
Yeah, so x is the base. That's where it's important to define the variables so you know what you're doing. X plus 1/6 is the height. What does it ask for? Well, actually, it did ask for the base. I would have asked for the height. So the base is 4/3 inches.
I wonder if they want it in a decimal form since it's lame.
I would go maybe 1 1/3. Um, inches, definitely not a decimal. I mean, you don't round, you don't create a rounding situation unless you have to.
Got it. Okay. You get that now.
I'm
Here's
mostly concerned that you know how to do this fractional completing the square. So if you want, I can give you another type of completing the square like this. I feel like you got it, you know.
um, let's do, uh, let me put this question out, do this, and then right, let me put this one.
What is this, a new one?
Yeah,
Oh, yes. Yeah. Okay. Copy. All right. A ball is projected from the ground into the air to 80 feet of 80 feet per second. At what time is the ball 84 feet off the ground? This requires you to know the projectile motion equation. Um, do you know the projectile motion equation?
we went over it in an earlier lesson.
I think it's unfair that they ask you to know this, but it's the initial height plus the initial velocity times time plus 1/2 the acceleration times time squared. The given quantity here, 80, is the initial velocity. That's V0. If you take a physics class in high school, which I don't know if I'd recommend, I mean, it doesn't count towards college because it's algebra based. You know, I don't know. It's a side talk. Even the AP one isn't necessarily that good. Um, the from the ground means that the initial height is 0. The acceleration is minus 32 feet per second squared, typically. Does that look okay to you?
Yeah,
Okay, so those are the quantities. Now, what's happening here is the ball goes up, and everything that goes up must come
down.
crashing down. All right, when is the ball 84 feet off the ground? So this one's asking, when is it above 84? And we don't know where that is. Like, truthfully, it could never reach it. It could reach it. It could reach it one time. Like, we actually have no idea. So we're just drawing a general picture. So our equation is 0 plus 80t minus 1/2 32t squared, 80t minus 16t squared. If you're wondering why acceleration is negative, acceleration always goes in the, well, your acceleration is down, your acceleration is due to gravity. Gravity is what
Yeah,
causes things to.
I think now I can remember. She just told us to use negative 16t squared, or yeah, t squared and then like the velocity, which like in this case is plus 80 t or something like that.
Yeah.
Just gonna
Well,
drive rid of that. Yeah.
this equation's from physics. It's reasonable in certain situations. You like if you're working at NASA, you wouldn't use this equation, but it's great for just high school physics. Um, so because there's more to it. Yeah. But it is 1/2 AT squared. Acceleration is 32. It's negative though. Acceleration is not always negative, but because it's gravity due to gravity, it's why it's down. It's opposing a motion. If you don't like that, you can go with what your teacher said, but that's the full explanation of why it is that way. Okay, so we care about when 80t minus 16t squared is greater than 84, which means we want to figure out when does it equal 84? 'Cause hopefully we'll get a couple of these x values. When we did a problem like this the other day, I recommended moving these to the other side. So it ends up being 16t squared minus 80t plus 84 equals 0. And then from here, you want to either factor or quadratic formula or completing the square. Actually, completing the square does work on this one nicely. The 16 goes into 80.
Yeah.
What would you like to do here?
I'm gonna do completing this.
All right. All right. So we're going to move that to the other side. You factor out the 16. It's not the greatest because it's 5/2. Now, when you square
25 over
that, it's
4.
25/4 times 16. So the 16 and the 4 cancel to make 4, so it ends up being 100. Sorry, that's not there. Sorry. 25/4 is there, plus 100 is there, plus 100 is there. It ends up being 16. That works out okay. Kind of okay, because when you divide by 16, again, we're solving for t. Take a square root of both sides, plus or minus. So we're going to add 5/2. P ends up being 5/2 plus or minus 1.
In this case, wouldn't it be the plus of it?
They actually both work. They actually both work. And the reason is projectile motion again. You're going up, you're going down, you're starting at 0. So you know that if there is a solution, it's going to be in between the domain of this.
Oh
So
yeah,
it's one
from yeah, yeah, okay, okay.
1.5 and 3.5 seconds.
Mm.
So those are the two times. So 1.5 seconds, 3.5 seconds.
Yeah, that's why I put between 1.5 and 3.5 seconds.
Well, you gotta be careful here. It says at what time is the ball 84 feet off the ground? It's not asking more than or above. It's just saying when is it exactly? So the
Oh, so
answer
it's
is just
and
1.5, yeah, and 3.5.
got it. All right. All right. Here is the next one in the chat.
Okay. Did your teacher typically work through these in class or like individual?
Usually we do some class examples on the notes. Um, yeah, usually do some in-class examples that are usually a little like some of them are kind of like the homework, some of them are just generally practice, but they're not like on the homework or
Okay.
the yeah.
All right. So we got a rectangle. It's got an area equal to 91 square feet. Um, the base is 1 foot more than twice the length. So this is where it's like, well, which is the base, which is the length. So we'll call that X. The length is X. So the base is one more than twice the length. Okay. Now, just as an aside here, there's only certain numbers that multiply to 91, like 7 and 13.
Yeah.
So sometimes you have to know the answer so that your work justifies the answer. Like this is not wrong. Like, we know what the answer is. Let's prove how we got it. That's okay too. Um, so what I want you to do is to show that the area, which is base times height, or 91 equals x times 2x plus 1, I want you to convince yourself that the answer is x equals, wait a second, one more than twice the length. Hang on. 7, 15. That doesn't work. Okay, this one, I take it back. We will work this out together because it's not working out the way I expected it to. Okay, so this is 2x squared plus x um, minus 91 equals 0. This could be a completing the square problem. It's not great because that 2 in front, that doesn't go into that. Um, the
So it might
factor,
be
you have to
better
multiply.
off just doing couldn't you do quadratic formula with the
You can always do quadratic formula, always, 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 but it's like the last tool that you want to use. You really don't want to use it as a first one, especially if you don't have a calculator. Do you have a calculator on this part of the test?
last time for the test I was expecting her to have like a separate portion for calculator, not calculator, but the entire test there was calculator allowed.
Okay, that
So the
might be a reason.
assumption would be that for this test it would be as well.
Okay, well, don't assume. Go ahead and ask your teacher, ask. Even if you don't want to do it in front of everyone else, just go either before or after, but you got to know. You got to know the rules that you're playing by. Yeah, why don't you try quadratic formula on this one then? And assume you have a calculator. That's fine with me. I'm going to do it as well on another.
All right, I got after using the quadratic formula, x equals 1.5 and x equals -7.
It should be 6.5. The -7 is right. What did you get for the part under the square root?
Um, so I got x equals -1 plus or minus square root of 729
Yes.
over 4.
Okay. So this is -1 plus or minus 27
Yeah,
over
that's what
4.
I got.
Right. So the 26 over 4, I heard 1.5. It should be 6.5.
Yeah,
All right. So if you're okay with that, 6.5 is the answer. Now, I made a comment earlier like, oh, it's 7 times 13. Well, I was assuming these were whole numbers. Clearly not. So, and this does work because 6.5 and then 2 times 6.5 plus 1 ends up being 14. 6.5 times 14 is 91. So while it could have been 7 and 13, it did not work out that way. These numbers do work, and uh, just a side thought there.
okay. Uh, I think now I can go back and do some practice with the fractions.
Okay, like completing the square with some fractions.
Yeah, kind of like that is the problem that we did before.
Okay, yeah. Let me grab. Think of something. Let me think of some here. Um, hmm, all right. Throw one at you here. Let's say it's x squared plus 1/3. I'll just put the right hand side here equals. Um, these don't have to work out nicely, do they?
Uh, yeah, I think I just found the problem with some problems like you have to put the decimal version of it. Some problems you look at the fraction, so it doesn't have to be a whole number. I don't think so.
Okay, let me just really quickly. I think I think it would be useful because these are all been working out somewhat nice. So just give me a minute here to
All right, yeah,
work
no
through
problem.
some calculations to see what and then let's go. No. Wonder teacher really worked out nicely. Most of them do not. Um, this is my last attempt to try to find one that works out nicely. Um, all right, let's just go with we'll just go with that. It doesn't work out nicely, but that's okay.
Yeah, squared. Would you have to answer in decimal form or
Just give me what you got inside parentheses here. What did you put down here?
inside parentheses? X plus 1/6 squared.
Okay, and what did you add to both sides?
I believe I added I think, one 136 or one
One
over
over
one
30.
thirty six.
Good. What is this on the right as a fraction when you add it together?
I got 37 over 36.
Okay, good, good, good. All right, now I did find a couple that do work out like nicer. So do you want the final? I mean, the final answer here is -1/6 plus or minus the square root of 37 over 6. And I don't know what that is, but that's, that is the answer.
I got
But
x equals -1/6 plus or minus 6 square root 11 over 36 because I tried to simplify the top. That's
37 does not reduce as a root. It's a
no,
prime
but we
number.
multiply it by the square root of 36 when you're getting me the square
No,
root
no.
on the
If
bottom.
if if you can take the square root of the bottom, or if you can take the square root of 36, you do it.
Oh,
Yeah.
so it just simplifies to 6. Oh, got it.
Yes. Yes. And often these match. Like that's pretty common for these to be the same
Then you just
denominator.
put would you just put, actually, no, you can't put them over the same denominator
Well,
because
you
the
could, you
plus or
could, you can say
minus.
-1 plus the square root of 37 over 6. That's okay. I didn't give you a great problem. Let me give you a slightly better one here to work on. X squared minus 1/5 x equals 1/10. This one does work out nicely, I believe. At least, I think it does. Oh boy, this one doesn't work out as nicely as I'd hoped. I should have, what could I have done here? Guess I could have made it 12. Can I change a number? Can I change that to 12?
Right.
And then it'll work out nicely.
Oh yeah, yeah, that does work out nicely. Yes, sir. Let me get X equals -1. Sorry. All right, I got X equals -1 plus or minus 11/10.
Good. And they do, let's just say this is a physical problem. The positive one is 6/5. The negative one is, or it ends up being -1. So probably keep in mind, probably using the positive one for this. So, okay. Pretty much out of time for today. How do you feel going into tomorrow, day before the exam?
Pretty good.
pretty good. All right.
Yeah, maybe it's more